Well, I received your question. I went ahead and started working on it here. Compute P of X using the probability binomial formula. Looks like you did that part okay. Then determine where normal distribution can be used for this. And it looks like you worked that out okay. If so, approximate P using the normal distribution and compare the results with the exact value. Okay, so that's what we're doing down here. Okay, use the normal distribution. Use a standard normal distribution table. So you don't have to go to the back of the book and look up z-scores. So first thing, to use the normal table, you need to know the mean. And the mean is n times p, which n and p are given here, which comes out to 43.4. And you need to know the standard deviation, which is square root of n times p times quantity 1 minus p, which comes out to 3.608. So now we want to find P of x equal 47. If we want to use the standard normal distribution, then we got to go 0.5 on either side of 47. So we got to find P of 46.5 is less than or equal to x, and x is less than or equal to 47.5. And so we need to find a z-score for each of these. Then we'll go to the table and look up those z-scores. Well, we have this value. We know the mean and the standard deviation, so we can calculate the z-score. So if I calculate the z-score here, the z-score for the 46.5 minus the mean, which was 43.4, over the standard deviation, which is 3.608. Well, that'll come out to a z-score of 0.8. You round it, tables in the nearest hundreds, so you round the nearest hundreds. I need to repeat this, find the z-score for this value here. And so the other z-score I need, supposed to be a z there, is 47.5, and then the other numbers will be the same, the 43.4 over the 3.608. And I get a z-score of 1.14. So I found the z-score for each of these values, and so that'll convert that. If I convert this to a z-score, it'll be P of 0.86 is less than the z-score, and the z-score is less than or equal to 1.14. And so you need to look up 0.86 in the table and 0.14 in the table. Let me move this over a little bit. I've already looked them up in the table. So 1.14, I looked it up in the table, and it's 0.8729. Move this more over here. So again, I looked up the z value for 1.14, and this is what I get. I need to subtract the z value for 0.86, and I looked that up here, and it was 0.8051, and then that works out to 0.0678. So I get that answer there, and if we go back and check that, that is one of the acceptable values here. Okay, so I'm using a normal curve. Hope this helps.